quick question, and it was question number. It was this question. B, part second, like this one that I have opened.
Mm-hmm.
This we have to do. Part second.
Yeah. Okay, so explain why the ray of red light follows the path it takes at D.
Yes.
Okay, so the path it takes at D, um, uh, it's because the red light is refracted the least.
Yes. So the angle it's mixed with normal shown. Complete the diagram to show what happens to the ray at point E. So first what you have to do,
Okay,
first you have to complete this diagram, okay? And then you do it.
okay, all right. Um, right. Let me get the ruler. One moment, just need to get my ruler. Um, Okay. So to complete the diagram to show what happens to the point to the ray at the point E. Okay. So if it's refracted the least, um, so when the ray slows down, it'll bend towards the normal.
Yes.
Okay, so it's gonna bend slightly towards the normal.
Yes. So when it enters, then it went towards the normal. When
Mm-hmm.
it leaves, then it bends away from the normal. So like at E, it will bend away from the normal because light is entering from denser medium to rarer medium.
Okay.
Because glass is denser, air is less denser. So when it is moving from high density area to low density area, it moves away from the normal. Whereas when it's entering from rarer to denser, that means from air to glass, then it will bend towards the normal.
Okay, alright then. Okay, so it'll bend more towards the point C.
Yes.
Okay. And explain why it follows the path at it takes at D, because it is refracted the least.
Yes.
Okay, now I see. Name the optical fibers play an important role in communications. Name the process the by which the ray follows the path shown.
Yes.
Its reflection.
It's total internal reflection. So like
Oh,
definitely it's a reflection, but it's a total internal reflection.
okay.
So is it clear what's total internal reflection? First, tell me, can you explain me what's total internal reflection?
Okay, total internal reflection is when the light that enters a medium, it gets reflected in it over and over again, and it doesn't shine out the other end. It just stays trapped in there, being reflected again and again.
So basically the thing is when light enters at an incident
Hmm.
angle greater than the critical angle, then only it's
Okay.
possible. If the angle is lesser than critical angle, then total internal reflection is not possible. Then it's only refraction that's possible. But what happens is when angle increased by or beyond the critical angle, in place of refraction, it's the total internal reflection that happens. And like instead of refraction, it gets reflected multiple times inside an object. So that's total internal reflection.
Okay.
So it's very important that you should mention that when angle of incidence is greater than critical angle, because if it's not greater than critical angle, then total internal reflection is not possible. Okay.
Yeah.
Okay, now next, name a medical use of optical fiber.
A medical use of optical fibers. Um, uh, um, it's used for an endoscope.
Its optical fiber is used for endoscope. How?
It's the fibers are put in through a long thin imaging device that's which is an endoscope, and it's used to view objects through a small hole.
Yes. So like basically it is inserted in an instrument. Okay. And basically what happened
Okay.
is that not all the type of endoscope uses this, but yes, some of the endoscopes they work on the optical fiber where they allow the light to transmit through that. Where there is an involvement of light, there the optical fibers are used in that kind of endoscopy. Okay, generally it's
Okay.
the filament lamps that are used, but nowadays
Mhm.
it has been replaced with optical fibers.
Okay. Right. No, not D. Um, so state two properties which are unique to all electromagnetic waves. Okay, so they travel at the same speed in a vacuum.
Yes.
Um, so travel at the same speed. Mm. And they're and they can travel through a vacuum.
Okay, so state two properties which are unique. So first thing
Okay.
is that they don't require medium to travel. That's correct that they can travel through vacuum. Why they can travel through vacuum? Because they doesn't require any medium. That's the first property. And second property is
Hmm.
also related with the vacuum or air, but it has something to do with. Okay, try to think, then I'll tell you. Like you think what happens when they travel in vacuum?
Um, when they travel in vacuum, well, they travel at the same speed in a vacuum.
Yes. So that's the second property that all the electromagnetic waves travel with the same speed in a vacuum, that is 3 into 10 to the power 8 meters per second. Right?
Okay, yeah.
So these are the two properties. Okay, now
All
facts.
right. Okay, second one. Next one. Let me just get that.
Okay.
Okay. Um, the name of the wave which detects banknote forgeries. Oh, ultraviolet.
Yes.
The danger can cause can cause wait,
Burns.
it burns. Yeah, it can cause burns. Using burglar alarms to detect intruders. Um, it's infrared.
Yes, that's correct.
Okay, and gamma waves. They can cause cancer, and um, it's used in um, uh, it's it's used for sterilization.
Yes. Sterilization or like medical imaging or in cancer treatment. These are the uses of gamma radiation.
Okay. Um,
Okay.
right.
Now
So
part
the
two.
next one, yes. Uh, so from increasing wavelengths, so we've got X-rays, visible light, and microwaves.
So name the electromagnetic wave that should be in box marked A. At A.
Um, uh, wait. So at A, the okay, name the electromagnetic wave that should be in the box marked A. Is it um is it gamma?
No, in the first, they're in increasing wavelength. You tell me which wave has the shortest wavelength and which has the longest wavelength.
Um mm, the shortest wavelengths well X-rays is well
In electromagnetic spectrum, you tell me which one has the shortest wavelength.
the X-rays
It's gamma rays.
gamma.
So here it should be the gamma just before X-ray. Then it's ultraviolet. Then it's visible. Then it's infrared.
Infrared.
Then microwaves. And then in,
Radio waves?
yes, it's the radio waves. Okay. Sorry, here it's ultraviolet after
Okay.
X-ray and here it's infrared. Then at the very end, it's at radio wave. So radio wave
Okay.
has the highest wavelength. Okay. And shortest
Mhm.
frequency. Now see this. The full scale ray diagram below for a converging lens is incomplete. You have to complete this. Complete the ray
Okay.
diagram to show the formation of image.
Okay. So I need to have that line through the center.
Yes.
Okay, let me just draw that. Okay, so I need to trace it back.
So it's a ray diagram that shows the formation of image, and it's a converging lens. Okay. So it's converging,
Okay.
which means I've told you you have to take two rays. One ray that is parallel to the principal axis, then passes through the focus. That means it's passing through the focus. And second, which passes through the focus and then after becomes parallel to the principal axis. Is this clear?
Yeah.
So first you have to write that where is the optical center, where is your focus, that you have to draw on this graph paper. Like if you have separate
Okay.
graph paper, you can do on that as well.
Okay, so the focus is where the ray meets the principal axis.
Yes.
Um, and I need to complete the ray diagram to show the formation of the image.
Yes.
So the image is going to be virtual.
First tell me where is the object? Position of
The
object.
object is it's behind the lens. It,
And like, okay, when we were studying the lenses, there are few cases, if you remember, right? So for converging
mm-hmm.
lens, It depends, your image depends on what? The position of the
Um,
object. Okay, that is the
okay,
position of
yeah.
the image. It depends on the position of object. Thing is, this is your optical center, and then you have to first find the focus. You just have to like locate the focus first.
Okay, locate the focus. And the focus is where the ray and the principal axis crosses.
Yes, that's your focus.
Mm-hmm.
That means a lens has two focus. If this is the distance on right hand side, the same should be on left hand side as well.
Okay. So the focus is seven boxes in front of the lens, so the other focus would be seven boxes behind the lens.
Yes.
Okay. I put in the focus. Um, and now I need to complete the ray diagram.
Yes.
Okay. Okay, I've drawn the image, and it's um, and the image is virtual and upright.
Okay, so virtual and upright, that's correct. And it's enlarged or diminished. Like what's the length?
Um, okay, so the focal length in millimeters of the lens.
Like
Um,
if I say like what's the
okay,
final image, the length of final image, which means you just have to compare it with the real object, the length of the real object. So it's larger than the real object, taller than the real object, or smaller than the real object, that you have to tell me.
it's larger.
Yes, that's correct. Now moving on to the next one.
Okay. Right. So what is the focal length of the lens in millimeters?
Yes, so draw,
Okay.
like calculate it.
Okay. So the focal length is I got 60 millimeters.
Yes, that's correct.
Okay.
Now the next one. Which two of the following words best describe the image?
Um, right. Let me get that. Um, wait, let me just find that. So the two words which best describe the image are it's erect
Yes,
and it's virtual.
yes, that's correct.
Okay. The magnification of the object may be calculated using the formula by taking measurements from your completed ray diagram. Calculate the magnification of the image.
Yes,
Okay. Magnification of the image. So height of image divided by height of the object. Okay. So the object is 3 centimeters.
yes. And what's the length of image?
Um, 4.5.
Yes, that's correct.
Okay. So the magnification is 1.5.
Yes, so you have to divide that height of object divided by height of image divided by height of object. So 4.5 divided by 1.5. Like it's 4.5 divided by 2. What was the height of image that you have calculated?
The height of the image was 4.5.
Yes, and of object?
3.
Yes, so 4.5 divided by 3. That is
Okay, so
1.5.
that,
Yes, that's correct.
yeah, okay.
Okay, now what?
What,
Yes, yes,
yeah,
continue.
what name is given to the converting lens when it's used to produce an image of the type shown opposite? Um, it's a magnifying glass.
Okay. So when used to produce an image, the type shown below. So yes, that's correct. A magnifying glass. Okay, the next one.
B. Um, I would so to investigate the properties of the image formed by a converging lens, a student set up the apparatus as shown below. They placed a wire mesh object illuminated by the lamp at various distances from the lens. For each object distance, the screen was moved until the best image was seen of the screen. How would the student know where the best image position is located?
Okay, first tell
Mm,
me, is this question clear?
yeah.
Okay.
Uh,
Now you.
okay. So, how would they know when the best image position is located? The image would be sharp and clear. Um,
Yes.
like
Yes, more focused, you can say sharp and clear or sharp and distinct.
okay.
Okay, now the next. Are the images in this investigation real or virtual?
Um, real or virtual? Um, it's uh real
Yes, it's real. And
because it can be shown on a screen.
yes, because it can be taken on screen. Okay, now the third part. The student made a note of the object distance and also the distance between the object and image. The results are shown below in this table. And what's the question? You
Okay.
have to plot the graph for this.
All right. So we've got the y-axis already plotted. So distance between object and image, and the x-axis is object distance. So it goes from 25 to 30, no, 25 to 50,
Okay, yes.
and there's one, two, three. There's 6 spaces. Okay. So can you add in like additional spaces or
Like in graph that you're saying?
yeah,
So, where here in distance, object in distance, that you are saying like you have to write.
yeah.
Yes, you have to write that according to the
Okay.
table. So distance are from
All
25 to
right.
50. So what you can do, you can take a distance of 5 centimeters or 10. You can take 10, like 10, 20, 30, 40,
Mhm.
50 that you can do, or you can do as 25, 30, 35, 40, 45, 50 that you can do.
Okay. Okay. So I'll go up in fives using the smaller squares.
Yes.
So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, and 60. Okay. So at the point at the distance 125 and 25. Okay. Okay. And now we um, draw the best fit curve through the points.
Yes.
Okay. Okay, I've drawn the curve.
Yes.
Um, and now number 4.
Yes.
Okay. Um, when the object and image are at their closest distance apart, the object distance is equal to twice the focal length of the lens. Using a graph, estimate the focal length of the lens used.
Yes. So use this graph and calculate the focal length.
Okay. So the focal length. Okay, so the object distance um and the image. So they're at their closest distance apart.
Yes.
Okay. Right.
So what's the length that you calculated?
um right. So the okay. So well the object and the object and the distance between the object and the image. Um, they're the closest distance apart at like 45 and 81.
Okay.
Um,
And you have to measure that.
yeah. Okay, so It's the closest distance apart at 40 and 80.
Yes, it's like the points are 40 and 80.
Okay. Um, and the the object distance is equal to twice the focal length of the lens. So the object distance is um so the minimum is at 4080, and the object distance is 40.
Yes. So then focal
So
length is?
focal length is half that, so it's the focal length is 20.
Yes, that's correct. Okay, now part C.
Okay. On the diagram below, complete the paths of the two light rays to show what happens after they emerged from the concave lens. Okay, so right. Um, okay, so a convex lens will like converge it, so like they'll like all come together. So a convex lens um will like diverge it, so they'll all go apart from each other.
Yeah, so convex is converging and concave is a diverging one. Since it's a diverging lens, that means it diverges.
Hmm.
So they move away from each other, the rays.
Okay.
Now question 4, and see this circuit using a 20 volts battery. Calculate the ammeter reading. So it's A right there. So you have to calculate the reading of ammeter when the switch is closed. Show clearly your calculation starting with the equation you plan to use.
Okay. Let me just get that. Okay, so a circuit was set up using a 12V battery as shown below. Calculate the ammeter reading when the switch is closed. Okay, so the ammeter reading. Okay, so we've got the resistance and the volts. So, and the the ammeter measures the current. So, the current is Q.
Yes. Current, it's
So,
I, like current if you denote it with I.
oh, current is I, and to work out current we do so current is V divided by R, so voltage divided by resistance.
Yeah. So first you have to calculate the total resistance.
Okay, so the total resistance is 4 ohms plus 4 ohms.
Which is 8 ohms.
Mm-hmm. So 12 divided by 8. So
So what's 12 divided by 8?
I'm just working it out. So it's 1.5
Yes, that's correct.
amps.
Yes. So it's total current. Okay.
Mm-hmm.
So the current that you have calculated, it's the total current. And why this total current is also the reading of ammeter, because in ammeter, the current that you can clearly see that ammeter is connected in series. So in series, the total current remains the same throughout every component. And that's why 4 ohms and 4 ohms, these two resistors you have added because they are in series. Okay. So
Okay.
in series circuit, the current remains the same, and in parallel circuit, the voltage remains the same. So whatever be your total current, that should be the same current for every component if they are connected in series, and that's why the reading of ammeter is your total current, that is 1.5 amps.
Okay.
Now
So when when the switch is closed, what will the voltmeter read? Okay. So we're looking for the voltage now. Voltage is I times R, and when the switch is closed, the circuit will be complete and the voltage flow through. So 1.5 times 8.
so what's the total current total voltage that you have calculated?
12 volts.
Voltage is V is equals to I times R. Your total resistance is 4. Like,
Okay.
okay, not this total, you have to calculate the voltage for this circuit only, because it's a
Okay.
series circuit clearly. That means on every device the voltage drop is different. So you have
Mhm.
to calculate that only for this part. That is 4 ohm and voltage, they both are connected in parallel circuit. Okay. So
Okay.
for this, your resistance is 4 ohm, and the current that is on this whole part is what? 1.5. So V equals IR. I is 4. I is 1.5 and resistance is 4. So your total voltage is basically 6 volts. Is it clear, or
Okay.
like should I clear you?
Yes, it's clear.
Okay.
It's clear. We're only looking for the voltage of the of the one with the voltmeter.
Yes. So that's it.
Okay. All right. Question B. The circuit is then altered by connecting a 2 ohm resistor as shown below. So calculate the total resistance of this altered circuit. So, okay. All right. Um, so, um, so there's an additional 2 ohm resistor, and before we had the resistance was 8,
Yes.
but now it's 10.
No, 4 ohm and 2 ohm are in parallel. So you have to add them
Okay.
in parallel equivalent resistance.
Okay. Okay, so the equation is 1 over RT equals 1 over R1 plus 1 over R2.
Yes.
Okay. So 1 over 4 plus 1 over 2 and we need to like work out what RT is. So
Yes.
we bring over the 1 and it'll become a divide by 1 and we need to cross multiply the fractions.
What you have to do, you just have to add them and then inverse them. That you have to do. It's 1 over 4 plus 1 over 2. When you add, you'll get 3 over 4 and then you have to reverse that. You'll get 4 over 3. Is this clear?
Uh, no, not really.
Okay. So let me show you this. Serial components are in parallel circuit. So one resistor is
Mhm.
this and one resistor is this. This is 4 ohm, this is 2 ohm. That means your R equivalent is 1 over R1 plus 1 over R2. Your R1 is 1 over 4, R2 is 1 over 2. Okay. Then if you add them, you'll get 3 over 4. Is this clear?
Mhm.
It's 1 over R equivalent is 3 over 4. But you have to find R equivalent. If you want to find R equivalent, you just have to reverse this. You get R equivalent divided by 1. If you are reciprocaling this one, you have to reciprocal this also. So you'll get 4 over 3. Is this clear?
Uh,
Okay.
could you do that one more time?
Okay. So in simple, it's 1 over R equivalent is equals to 4 over
Mhm.
3. If you cross multiply, you get 3 equals 4 R equivalent. Is this clear?
Yeah.
And dividing both the sides by 4, you get 3 over 4 equals R equivalent. Is this clear?
Yeah.
So that you have to do. It's just a direct way that I was telling you, but if it's not clear, just stick with this one. Okay?
Okay.
Now you have calculated the equivalent resistance in parallel, then they both are in series with 4. Then what's the total?
Um. So wait. Um. Okay. So the total resistance was 1.33.
Yes.
Okay. And now we need to calculate the new reading on the voltmeter. Okay. Okay, so first we need to um, work out the amps, the current.
Yeah.
So I equals V over R. So the voltage is what?
You
The
have calculated
voltage,
the total resistance, right?
yeah,
Okay. Now it's you have to find the new reading of voltmeter.
okay. Um,